Hi, this is Alex. I'll be explaining quiz 9, question 1A and B. So in question 1A, we asked to find what's the width of the slit. Um, well, let's think about what do we know. So we know the distance between the diffraction pattern and the slit. So it's 2 meters away. And we know the light, the wavelength of the light is 400 nanometers, and we know the first order of the dark, so it's a minima, a dark and between the dark and the central, which means normal, at the normal line bright fringe, it's 357 millimeters. So this on a sketch, it looks like this. So these two um, here and here are 357, both 357 millimeters to the normal line here. It's a central line here, which would be the bright fringe, and the distance here would be 2 meters. And since we know this, we could calculate the angle. The reason why we need the angle is because that to find the distance between distance width of the slit, not distance of slit, width of slit, we need to use this equation. And we know m, we know lambda, and we know we're trying to find d, but we don't know theta. So we can find theta by using by looking at the looking at this by using Pythagoras. So tangent theta is equal to opposite over Jensen, which would be um, which would be 0.357 meters over 2 meters, which turned out to be, take the inverse of it, which turned out to be theta turned out to be 10.12 degrees. And then just plug in the value. We can find that d is equal to m times lambda over sine theta. Plug in the value, we can find that d is equal to 2276 nanometers. So in B, which I'll show the PDF real quick, we just put in these values on the website. The first option for the minima would be roughly 10.1 degrees, so that's very close. Well, we got 10.12 degrees, and this is the intensity profile. Very accurate. Yeah.